Our planet is a place of constant silent change. We often see it as a solid, unmoving sphere beneath our feet. But this is far from the truth. Deep within the Earth, immense forces are at work. They shape the world in ways we can barely comprehend. In the vast, sun-drenched landscapes of Eastern Africa, a truly extraordinary story is unfolding. And it's a story not of months or years, but of millions of years. Here, in the cradle of humanity, a new ocean is in the slow and powerful process of being born. A continent, one we have known for all of human history, is beginning to tear itself apart. It is a geological drama of epic proportions, a transformation that will one day redraw the map of the world. This process is not violent in the way we might imagine. It is not a sudden cataclysm. Instead, it is a slow, relentless stretching of the Earth's crust. It happens at a rate of only a few millimeters each year, about the same speed at which our fingernails grow. Yet, over the vast expanse of geological time, these tiny movements add up to create enormous change. Build mountain ranges, forge valleys, break a continent in two. This great division is happening along a feature known as the East African Rift Valley, a scar upon the land that stretches for thousands of kilometers. Imagine standing on the edge of this vast valley, the wind carrying the scent of acacia and dust. To understand what is happening in Africa, we must first look deep beneath the surface. The Earth's outer layer, the crust, is not one solid piece. It is broken up into a number of gigantic interlocking slabs, much like the pieces of a cracked eggshell. These are called tectonic plates. They are enormous, some carrying entire continents. Others vast stretches of ocean floor, and they are not still. They are constantly moving, floating upon a hotter, softer layer of rock beneath them known as the mantle. This movement is the engine that drives nearly all of our planet's geology, from the eruption of volcanoes to the shaking of earthquakes. These plates interact with each other in three main ways. Sometimes they collide, pushing against one another with unimaginable force. This is how the world's greatest mountain ranges, like the mighty Himalayas, are formed, as the crust buckles and crumples upwards. In other places, one plate might slide beneath another in a process called subduction, often melting as it descends back into the mantle, fueling a line of volcanoes on the surface above. And in yet other locations, the plates are not colliding but are instead pulling away from each other. This is known as divergence, and it is precisely this process that is now at work in Eastern Africa. The African continent rests on a single, massive tectonic plate, the African plate. However, this plate is not as solid as it once was. For millions of years, a giant plume of superheated rock has been rising from deep within the Earth's mantle, pressing up against the underside of the continent. The African plate is now in the process of splitting into two smaller plates. The great dance of the continents continues, and Africa is leading the next step. The most dramatic evidence of this continental split is etched into the landscape itself. It is the East African Rift Valley, a vast geological feature that runs for more than 3,000 kilometers, from the Afar Triangle in Ethiopia, down through Kenya, Tanzania, and Mozambique. This is not a single, simple valley. It is a complex system of fractures, escarpments, and deep depressions. In many places, the valley floor has dropped by hundreds, even thousands of meters relative to the surrounding highlands. In Ethiopia, it forms a wide, low-lying desert basin known as the Afar Depression. This area is one of the hottest and most geologically active places on Earth, where three tectonic plates are pulling away from each other. Further south, in Kenya, the rift splits into two parallel branches, the Eastern Rift, the Western Rift. Lake Tanganyika, Lake Malawi. The Eastern Rift, meanwhile, is more volcanic, dotted with famous peaks like Mount Kilimanjaro, Mount Kenya, which are actually dormant volcanoes formed by the rifting process. Walking or driving through the Great Rift Valley is a truly humbling experience. You are traveling through a zone of weakness in the Earth's crust. The valley floor is a mosaic of volcanic soils, shimmering soda lakes, and grasslands that support an incredible diversity of wildlife. A scar that will one day become a seaway. The slow stretching of a continent is not a quiet affair. As the crust is pulled thin, the stress builds up in the rocks until they can no longer hold. They snap. This sudden release of energy creates earthquakes. The entire East African Rift Valley is a seismically active zone with frequent, though usually small, tremors. These earthquakes are a constant reminder of the immense forces at work beneath the surface. They are the groans and creaks of a continent under strain. While most are too gentle for people to feel, seismographs record this constant chatter, mapping out the active fault lines that define the rift. Occasionally, the strain manifests in more dramatic ways. In 2018, a massive crack several kilometers long up to 20 meters wide suddenly appeared in the ground in southwestern Kenya. It split a major road and forced people from their homes. Heavy rains had washed away soft soil, revealing a deep fault line that was being pulled apart from below. Volcanic activity is another key sign. As the crust thins, hot molten rock or magma from the mantle can more easily push its way to the surface. One of the most remarkable is Old Duino Lengai in Tanzania, the Mountain of God. It is the only active volcano in the world that erupts nitrocarbonatite lava, a unique, cool black lava that flows like motor oil. The presence of such active volcanism, along with countless steam vents and hot springs bubbling up from the ground, shows just how thin and fractured the crust has become here. These visible signs, the earthquakes, the fissures, and the volcanoes, are all interconnected symptoms of the same underlying cause: continental rifting. They are the birth pangs of a new sea. So, how does a crack in the land become a vast ocean? Well, the process is a magnificent multi-stage sequence that unfolds over millions of years. It begins exactly as we see in Africa today, with a continental rift valley. First, a rift valley. Then a narrow sea like the Red Sea. Finally, a wide ocean with a mid-ocean ridge. As the two plates, the Nubian and Somali, continue to pull apart, the valley floor between them will keep sinking. The stretching and thinning of the crust will just intensify. The land will subside further and further below sea level, even though, it might still be dry land for a really long time, protected by the highlands on either side. This will most likely happen first in the north, in the Afar region of Ethiopia. Here, the land is already very low, in some places more than 100 meters below sea level. The Red Sea and the Gulf of Aden, which are themselves young oceans formed by the same rifting process, are separated from this depression by only a narrow strip of land. Eventually, this barrier will be breached. Seawater will pour in, flooding the low-lying rift valley. What was once a dry, dusty valley will become a long, narrow seaway. At this point, the process really speeds up. Magma will well up from the mantle to fill this gap, solidifying to form new oceanic crust. This is the same process that happens at mid-ocean ridges all over the world. This is the moment a new ocean is truly born. The splitting of Africa may seem extraordinary, but it is a story our planet has told many times before. The current configuration of our continents is just a temporary snapshot in a long history of geological change. If we could rewind time by about 200 million years, we would see a very different world. All the continents we know today were joined together into a single, colossal supercontinent. Geologists call this landmass Pangaea. There was one continent and one gigantic global ocean, Panthalassa. The breakup of Pangaea is perhaps the most famous example of continental rifting in Earth's history. Just like Africa today, Pangaea began to stretch and crack under the influence of rising mantle plumes. Rifts formed, which eventually grew into young oceans. One of the first and most significant of these splits was the one that opened the Atlantic Ocean. North America, Europe began to pull away from each other, South America, Africa. If you look at a world map, you can still see how the coastlines of South America and Africa fit together, like pieces of a giant jigsaw puzzle. This is the most compelling evidence of their past union. The process that formed the Atlantic Ocean was identical to what we are witnessing in the East African Rift. It began with valleys, volcanoes, and earthquakes. Then a mid-ocean ridge formed down the center, creating new seafloor and pushing the continents apart. The Atlantic Ocean has been widening ever since. The opening of the South Atlantic provides a perfect blueprint. So what will our world look like when this process is complete? We must peer far into the future, for these changes happen on a timescale that dwarfs human history. In about 5 to 10 million years, the changes will be dramatic. The Red Sea will have flooded the Afar region. The Gulf of Aden will have flooded the East African Rift Valley. A new, long, narrow ocean will form across eastern Africa. This sea will separate the Somali Plate, Somalia, eastern Ethiopia, Kenya, Tanzania. A large new island, the East African Island, will have formed. The new sea will be dotted with volcanic islands. These islands are the tops of underwater volcanoes along a new mid-ocean ridge. The rift's steep escarpments will become coastal cliffs plunging into the sea. Cities now hundreds of kilometers inland could be much closer to a new coastline, Nairobi. The geography of the region will be completely rewritten. Africa, as we know it, will no longer exist. It will become two landmasses, the large Nubian continent, and a new, smaller Somalia continent. Looking 50 million years ahead, The new ocean will have widened considerably. It might be as wide as the Red Sea today, or even wider. The Somali Plate will have drifted far into the Indian Ocean, a distinct landmass perhaps similar in size to Madagascar, or similar in size to New Zealand. The birth of a new ocean is an almost geologic certainty. The immense geological forces that are tearing Africa apart also have a profound and creative impact on life. The changing landscape of the Rift Valley has played a crucial role in the evolution of countless species, including our own. As the valley floor dropped and the highlands rose, new environments were created. Forests gave way to savannas, formed lakes disappeared. This constantly shifting mosaic of habitats is thought to have been a powerful engine of evolution driving species to adapt to new conditions. Indeed, many of the most significant fossil discoveries of our early human ancestors have been made right here within the Rift Valley. Today, the valley's unique geology continues to shape the lives of the plants, animals, people who call it home. The volcanic soils are incredibly fertile, supporting rich agriculture in some areas. The deep rift lakes like Tanganyika, Malawi, are cauldrons of evolution, home to hundreds of species of cichlid fish found nowhere else on Earth. The soda lakes, such as Lake Natron, Lake Bogoria, are so alkaline that few creatures can survive there, yet they provide the perfect breeding ground for vast flocks of lesser flamingos who feed on the algae that thrive in these harsh conditions. The geothermal energy bubbling up from below also presents both opportunities and challenges. The steam vents' hot springs are a potential source of clean, renewable energy, and countries like Kenya are already harnessing this power to generate electricity. However, the volcanic activity and earthquakes pose a constant risk to the communities living within the rift. People must learn to live with the unpredictability of the ground beneath their feet, adapting their buildings and their lives to a landscape that is actively, and sometimes dramatically, in motion. As the rift continues to widen, a new sea begins to form, life will adapt once again. It shows us that even as the very ground splits apart, life finds a way not just to survive but to flourish in new and unexpected ways, turning a geological crisis into a biological opportunity. The story of Africa's splitting continent is a profound lesson in perspective. In our fast-paced world, we expect change in days, weeks, or years. But the Earth operates on a different clock. Its pulse is slow, measured in beats that last millions of years. The separation of Africa began long before the first humans. It will not be complete for millions more. The changes are imperceptible in a single lifetime, yet they are powerful enough to build mountains, and to create oceans. To witness the East African Rift is to see a planet at work, to stand on the edge of a future ocean and feel geological time. It inspires wonder and humility. It reminds us the world map is not permanent. Continents are cosmic rafts on a sea of molten rock. Our planet is living, breathing, ever-changing. This slow-motion drama puts our existence in context. We are temporary residents on a remaking world. The same forces split Africa and regulate long-term climate. They recycle elements essential for life. They have driven evolution for billions of years. Understanding this helps us appreciate the systems that make Earth habitable. It's a story bigger than any one of us. The story of the ground we stand on. Next time you look at a map, remember it's not final. See the Great Rift Valley not as a scar but as a cradle of a new ocean. A powerful reminder Earth is alive. We are privileged to witness this chapter being written.